Today we'll be talking about group replication. I won't be doing most of the talk. Nuno will be doing most of the talk. Before anything else, let me introduce us both. My name is Soares. I'm the MySQL replication lead. So I basically handle mostly everything related to the replication at MySQL and HA and whatnot, except for MySQL cluster. And then Nuno here is leading part of my sub-team on the group replication part of things. So he's the one that handles most of the things related to group replication and reports to me. As I said, today we'll be talking mostly about group replication. And this is the proposed set of topics for this session. So just briefly go through the background for replication at MySQL in general, talk a little bit about the use cases for group replication, detail how you can deploy the MySQL group replication plugin, talk about its features, talk about its performance, and if we have the time, go a little bit into the details about how the plugin came to be or how the plugin is structured architecturally within the MySQL architectural context, and then just conclude the session. So background, what we'll be talking today here is about replication in general, and then more specifically about group replication. But replication, it's something more or less like this. We have some change that is performed in some server, and then we need to replicate, propagate this change to a different server. In this case, we see here server A and then server B as the replica. It's pretty simple. But the devil lies in the details. So this is the traditional or the high-level overview on MySQL replication architecture, both for asynchronous replication and for group replication, if you will. So we have a server that executes transactions. These transactions or the changes of these transactions are captured in a log. We call it a binary log. And then there's some communication framework to propagate the changes from this server to another server. There's a persistent buffer on the replica, which we call the relay log, and eventually these changes are applied to that server, and that server is brought in sync with the other server. So the communication framework is really what is most different, what differs the most for MySQL asynchronous replication and MySQL group replication. Right? In asynchronous replication, this communication framework is the MySQL replication protocol. It's peer-to-peer, it's asynchronous, and so on and so forth. And in group replication, we have this communication framework that relies on a Paxos implementation to secure synchronization between servers, to use some properties like total ordering of messages, safe delivery, and all these things working together. Just a little bit on the history side. MySQL replication, asynchronous replication exists for a very long time, since 3.23, natively inside the server. So it's been a while since it's around. So it's pretty much battle tested. It's pretty much widely deployed and so on. In 5.5, we introduced this semi-synchronous replication plugin, which basically means that it's asynchronous replication, which requires an extra communication round between the master and the slave, so that the slave can inform the master that the changes that it has received have already been written to the relay log, to its persistent buffer on the slave. And late December last year, we did the group replication release for 5.7 as a plugin as well. So it's been out there since 5.7.17. And as of 2 weeks ago, we released MySQL 8.01, and it's the first MySQL 8 release that includes the plugin as well. So both 5.7 and 8.0 have the plugin in their releases. So what is MySQL group replication? It's a single multi-primary update everywhere replication plugin for MySQL with built-in automatic distributed recovery, conflict detection, and group membership. This is a very long definition, but basically it means that in addition to do data replication, there are some other properties that the plugin gives, provides the server with, like which servers exist in the group, has the server failed, and so on and so forth. This is all managed automatically by the plugin. So in the end, it removes, from the user perspective, it removes the need for handling server failover, provides fault tolerance, enables update everywhere while it's doing conflict detection and resolution, automates group reconfiguration, so you can just remove a server and the group will detect this and it will automatically reconfigure itself. So ultimately what this tries to provide is a base for implementing a highly available MySQL database service. And yes, this is the overview picture. So you have client applications, engaging servers in the group, issuing transactions on the different servers, and then you have some coordination to check for conflicts and to commit or abort transactions that you commit transactions that don't conflict, and if they conflict, you basically resolve the conflict by rolling back the transaction that is ordered later. So basically, the first committer wins, and the second transaction that is ordered after that one will just roll back. Just a little bit of description of the roadmap. We can see here that it all started a long time ago when we released 5.6 back then, and then we started working on changing the infrastructure, the replication infrastructure on the MySQL server to be able to do this kind of more advanced and pluggable replication frameworks. So we took this opportunity to refactor, to re-engineer, to start building this infrastructure that would allow us to later on release MySQL group replication as a plugin. In this process, we released a lot of labs releases. We engaged a lot, the community a lot. We got so many feedback. We adapted some of that feedback and changed the product so it slightly morphed from what it was in the beginning and what it came to be to what it came to be when we released it as a GA plugin. We added a lot of features, but the most interesting thing as well is, like I said earlier, we took this opportunity to do some refactoring and restructuring of the MySQL replication code. And we built infrastructure. And in the end, we can reuse these other bits and pieces that we have, built these bits and pieces or components that we're building and adding up to do something else. Like, for instance, there was a couple of talks about right-side-based parallelization for asynchronous replication. All this comes from this work that was done to enable group replication plugin, but also other components in the regular asynchronous replication framework. And this month, in 11th of April, we also released this 801, as I said, but we also released this InnoDB cluster, which is a framework that builds on top of group replication to provide a simple user experience, an easy-to-use system based on top of group replication. So it's easier to deploy, easier to start, easier to manage a group replication cluster. And Frederick and Matt Lord demonstrated it at the beginning of this conference in a whole day tutorial. So use cases, there's several use cases for group replication, for instance, elastic replications. Given its ability to auto-reconfigure, auto-manage itself, given the fact that it has a group membership service built in, it's easy to add and remove servers from the group. The group will reconfigure itself. It will do automatic or incremental state transfers if need be. If deployed in single primary mode, it will automatically select the next primary if the primary goes away, and so on and so forth. Also, if you're doing sharding, you could probably take this approach to build highly available shards. So each shard is a group, and then you basically route the queries to the shard that you want to route while keeping the shard highly available because it's a group. And it's also an alternative setup for master-slave replication with the additional guarantees that are additional properties that I have enumerated earlier on, right? The group membership, the total ordering of transactions within the group, the guarantee that you don't lose transactions if servers fail, and so on and so forth. So all of these things are provided by group replication, and I think I should stop now and give Nuno a chance to talk about it, and he'll be focusing on the features.
So thank you, Luis, for doing the introduction, and let's go now go to how we can deploy group replication. So we have two modes of deploying group replication. The first one is using a single primary, on which we have the group, but only one member is allowed to do writes. And the other ones are what we call secondaries, which are out backups and can all receive the updates, but only one is able to write. This is our default mode. This is the closer that we have to classic asynchronous replication setup. And this is why, because it's simple to reason about. It's easy for you to migrate from one to another. And also it makes the complexity that is attached with multi-master hidden. So we only have one primary, everything makes much simpler, and you can make your applications work. This also brings automatic primary election. So when the group is bootstrap, the primary is elected. And in the case of the primary fails, then the group itself elects another primary. So this has auto failover from built-in. There is no need to have a DBA to code, implement, or do manual failover. This is built-in on the system. Also, you can see which is a primary member by selecting a global status var, which is the group application primary member. It will display the member ID that is a primary currently. Then we have, of course, the multi-primary mode. On this mode, each member can do writes. It is made for really high available setups. And of course, if you have multi-primary, then the things become a little more complex and you can have conflicts. If you have transactions happening on parallel in different servers, touching the same row, then you have conflicts. If transactions are not conflicting, like the ones on the slide, they are touching different rows, then okay, both can go in parallel and commit. But if they touch the same row, then the rule is the first one to commit is the one that wins. And the second, or more than the second, needs to roll back to avoid inconsistency. This is one of the main difference between the multi-primary and the single primary. But you have more HA within this mode. And now I'll do a small walk through the features. And the first one is automatic distributed server recovery. So when you create the group, it is okay, everything is going, but you want to add another server to the group. The system itself, it knows how to handle that, and you join the member contacts the group, it goes to recovering state, and while it's on that state, it is fetching the missing data that the group has, and the new server doesn't. And while it's doing that, it is recovering, and it does not allow writes on it. So it's protected for that. When it does catch up, yes, please?
Sorry. This means that the node already needs to have an initial of a set, or can start from scratch?
It can start from scratch, but it will take more time, of course.
Yes, of course.
Yes. So we advise people to provisioning before, and then just do a small recovery, like a few seconds. If you start from the beginning, it will take more time.
And the node that is providing the data to the one recovery will be put in offline state, or?
No, the one that is providing data, it's still online, but it needs to deal with the writes and also downing the data. And then when it is over, it becomes part of the group, it is online, and everything is normal again. So there is no need to implement, to code anything. It's just join and the server and the group will take care of this. Every action that we have on the group, so a server joining or a server leaving, it updates the membership. The group always knows what are the members of the group. That is tagged with a version that we call view ID. So anytime that the server joins or leaves, the view ID is incremented. And you can consult on the from schema tables, which is the view ID that you have, and see how the system is progressing. So if you have a group running and a server crashed, you were on view ID number 4, now you are on view ID number 5. You joined again, goes to recovery, goes to one line, and is back again. So the system knows how to handle this, and it just works. But more important than this is that even when you use a multi-master setup, this is still MySQL. So you don't need to change your application for this to work. We are a MySQL plugin, nothing is new. We use InnoDB, you have the same API, the same guarantees. We did some optimizations to InnoDB to make the system perform better, but it's built in. You don't need to care about that. And also, all the monitoring that we provide on group application is based on from schema tables, but that already happens with normal applications. So again, nothing new. We're just extending what we already have. So what is the outcome of this? We are no alien component. We share the same look and feel as the server. If you know how to work with MySQL, you know how to work out group application. It's out of the box. For already existing users, it's the same. So no big change. For new users that want to use group application, they only need to learn MySQL, not MySQL plus some external library. So it's all built in, all out of the box, all it works. Also, since we are the upstream, we do support full GTID. So like we have now on 5.7 and on 8.0 and on 5.6 also, we do support GTIDs. The only difference that we have here is that instead of having a UID for each server, we have for the full group. So the full group behaves like a single instance. But this instance, the group, supports fault tolerance. So when you do a commit, the UID that is used to tag that commit on the binary log is the group name. And it will take care of that, and it will increment, and if you do inserts like this one, 1 and 2, the GTID will be automatically assigned. But since we are the upstream, and if you want to inject some GTID, you can. Just use the command set GTID next, UID that you want, the number, and it works. So full support. This also allows us to replicate from external server. So imagine that you have your old master and you want to migrate for your old master to a group. What is the best way or simple way to do it? You set up your master, set up a group, and you replicate from the master to the group. And that is supported, GTIDs are allowed, and everything works. Of course, there will be conflict detection, because that data stream from the master to the group needs to be validated that will not conflict with the data on the group. And you can also do the other way around. I want to add slaves to scale out the reads from the group. So you can hook up slaves on the group and just replicate from there. So like if it was a single master slave. Again, full support, out of the box, no changes needed. But since we have our own multi-master environment, or multi-primary, what would happen if we all use the same auto-increment value? If we would have parallel transactions that have the same auto-increment seed or offset, then two parallel transactions will have the same auto ID, and they will go into conflicts. And this will be really, really bad for your performance and for your application. So to avoid that kind of situations, what we do is that we establish that each member has its own offset, which is the server ID. You can customize, of course, but by default it's server ID. And each transaction or each member has the offset of 7. So this makes that any member will never conflict with each other, even on parallel transactions that they do use the auto-increment. Why did you pick up 7 and not, for instance, the group size? Because if you would start with a group size of 3, and then you will go to a 4, and you forget, or the server will take too much time to update that value, then you have a window with the conflict will happen. So that's why we established the default of 7, But if you guys are sure that you'll never have more than a given number, like 3, you can set to 3 and maximize the auto-increment range for your case. But the goal here is never have conflicts that we can avoid. I don't have the link here, but there is a really blog post about this. I will give the link at the last slide on why we explain why the 7 is a magic name. So there is math behind that. You can later read the blog post. Then, of course, everybody now asks, what about upgrades? So how can I upgrade a server? How can I upgrade a member? How can I upgrade a group? This was made built-in with that in our minds. So if you have a group and you want to join someone with the same patch version, like 5.7.15 and 5.7.12, it is allowed to join with any restrictions. So they are the same major version. It must work, and it does work. But if you have an 8.0 group that you can make now since 2 weeks ago, and you want to add a 5.7 member, it will not be allowed. And why? Because that member may not be able to understand the message from the 8.0. Actually, our protocol, it does support that. 5.7 knows how to talk 8.0 on group application. But there may be behavior change on 8.0 that 5.7 is not aware or is different. So if you allow to us 5.7 or 5.6 or 8.0.9 to join when that kind of situations happen, there could be behavior change that will make the data inconsistency on that server. So by default, we don't allow lower member joins to join a group with a bigger version. If you really want, like on a panic mode situation, my cluster is down, I need to add someone to make this alive, you can. There is an option to force that, to make the liveness available, but you need to be aware that that's a compromise. So I want to make it alive, but I may have issues because of the different versions. On the opposite case, so we have a 5.7 group, and you want to join an 8.0 member. You can, it is allowed, but 8.0 member is by default read-only. It is not able to do writes. Why? Because then we'll be on the same situation as before. The 8.0 will send message that 5.7 could not understand, or a different behavior that 8.0 and 5.7 have. Sorry. Yes, please.
Given that the standard instance replication is the same, I mean, still looking at view well, you can have 2 clusters, one on version 5.7 and another on version 8, communicating by standard replication.
Yes. Yes, because this behaves like a single instance, but it is a group with fault tolerance. Of course, if you replicate, you need to be the same careful that you need to have on a single instance. But yes. So whatever we support here, thank you, Fred. So we support everything that the single instance supports. So that's the main goal or main trade-off of being the upstream. Yes. So if it's on one side, we'll have on the other side. Also, we have a full built-in stack made by us. So we have a built-in communication engine, which is based on Paxos. It has already implemented compression. It supports multi-platform, Windows, Soares, Linux. Wherever MySQL does support, we do support. It has dynamic membership. It has distributed agreement. It has quorum-based message passing, SSL, and DP whitelisting. This comes out everything out of the box. We do not require any third-party software. It's everything made by us. We support everything. Also, we do not require network multicast. Why? Because then we'll not work on cloud installations. So we don't have that requirement so that you can run replication on any network you want. We have our safety measures, so like the read-only modes. Like I mentioned before, when the server or the member is on recovery, it is automatically with read-only, so no one can make writes. Also, on the unlikely event, it's making some echo, unlikely event of a member failure, the read-only mode is set on that member to avoid inconsistency. So that if you have a split brain, read-only mode is set and no one can go there and make writes. Also, that change is assigned with a state change to error state. That's why we have the red box there. And then, usual question, so is this secure? Yes. We have full stack secure connections. We have encrypted connections during the distributed recovery connection. We have encryption between each member on the Paxos layer, and we also have encryption on the client connections. On top of that, we also have EP whitelisting. So we can restrict which hosts can connect to each member. If you set a default value, which is automatic, what we allow is that on each host, the private networks that are active on the host are allowed to connect. So if you have a class C network, it will be allowed by default if you have automatic. Or you can express what you want to allow to connect to that. So if you have by default public IP on that machine, it will not be allowed. So safe by default, avoid intrusion of someone on our machines. And then, of course, we have parallel applier support. This is a really simple change for us. You don't need to change anything. It is configured the same way as we do for normal replication. You just set the parallel type to logical clock. Preserve commit order, it must be on. It's a requirement from us. You need to preserve the commit order on the group. And then you just pick the number of parallel workers. And it does work out of the box perfectly. If you were on Luis' session before or Jean-Francois this morning, you know that there is a new mode on 8.0, which is write-set-based transaction dependencies. This was made on group application and now was backported to normal replication. So even we on replication do not set this special mode, it's already there. It's already used internally. So we have write-set parallelization. It's really fast. There is almost no slave lag. Of course, it depends on the workload. But if you want to speed up the distributed time, you should set this up. That will make the recovery even more faster. And if you were on the Jean-Francois session, or if you see his blog later today, you'll see that you can have in sometimes 600% improvement in performance. So that's a really, really good result. And also, the new feature that we have on 8.0.1, we now support transaction SAVEPOINT on group application. This was missing, now it's there. There is no big thing to say here, but now we support that. And what are the requirements? And some are by design, some are not. So by design, we require InnoDB storage engine. Why InnoDB? Actually, what we require is a transactional engine. But we need special hooks to allow what we call hyper transactions. And currently, that is only implemented on InnoDB. But it's there out of the box, no need to patch anything. We do require primary key on every table. This makes our life easy and performance greater. And it's not a big change for the applications. We do require global transaction identifiers turned on. We do require binary log. We do require binary log row formats being set. And then there is the optimistic execution. If you are using multi-primary and with parallel transactions, there may be conflicts, and due to that there may be rollbacks. Also, we have a soft limit of 9 servers per group. Why 9? We do support more, but on our tests, on our performance testings, we saw that, and I will show later, that from 3 to 9 there were no performance degradation, or it was too small. So we support 9, which is more than enough to the usual cases that customers do have. Things that are forbidden when we use multi-primary. So we don't have serializable on multi-primary mode. That is mostly impossible. So I will not go into details, but if you want offline, I can explain why that this is not possible. We don't have cascading foreign keys support on multi-primary, and also we don't have binary log events checksum, though we do have checksums on our communication channels. So one can replace the other. Then a few warnings. DDL, so it's always the black sheep on the room. So if you issue concurrent DDL on a multi-primary setup, you may end up with problems, so you need to be careful. Or you should use single primary, so then we don't have issues. And also the select for update statement does not take does not take global locks. It takes the locks on the member that is running, but not on the actual group. So if you make that assumption, it may have different results than the ones you expect. So these are things that you need to be aware when you use a multi-primary setup. And so how does it perform? That's what it matters, right? So we have here our results. The gray line, it's the single server. That is the same result because it doesn't change. And then you can see on blue the results for the single primary mode, which is slightly slower than a single instance because we need to pay the fault tolerance trade-off. But if you go from 10 to 9 servers, it's the same performance. So you don't see degradation with more fault tolerance added to the group, which is really good. And then if we go to the multi-primary mode, what we call sustained and peak. Sustained is the maximum load the system can handle without having slave lag. So if you want to have the group almost in sync, then we are using the sustained throughput, and you see that it starts a little bit faster than a single instance, and then it degrades, but it degrades linearly. So it's a sustained degradation and what you can estimate on your workload. But if you have a case like, okay, I have my usual workload, but at 6 p.m. I have a really big workload, like people going out of jobs and going to Facebook to say something, then that will be the case of the peak workload. You can see that the system is even better than the single instance. But I need to reinforce that replication is not a right scalability solution. It is a shared nothing solution. And you see here better right results because the results are being split through the members. And since they interleave with each other, we have more room to make more commits. But it is not the goal of replication to scale out the writes. It does, but it does because the system is well designed and well implemented, but that is not the goal. And you'll never have really huge scale out because you're using replication. It does happen, but it is mostly a consequence, not the goal. And this is what I just said. And now going to the architecture. So how did we design and did we split the components that make replication? So this is built on top of proven technology. This is based on MySQL Replication. We do reuse the most of the components. And we provide the multi-primary approach to replication or single primary with fault tolerance. This is based on a layered implementation. We have new components, old components, and we make APIs between them. It is interface-driven development, so since we make the right-side parallelization on replication, it was easy to make it also useful on a single replication because we use APIs for that. It is decoupled from the server core. We are a plugin. And we usually register as listener for server events. And we also reuse the capture procedure that also already exists for semi-sync. Rather using that, and we couple everything together with a new network infrastructure, which allows us to make more guarantees and support the failures. So if you have an insight on top of inside of each group or each member, you'll see that we have the MySQL server, the API, our plugin, the communication API, and then the communication engine. If you guys know replication since the beginning, from 2 years ago, we did start with chorusing, And then on the middle, no, we need more, something better than this. And we did change CoreSync to our package implementation without a nightmare because we have really good APIs defined. So this structure that we have since day zero did pay off just in the middle of development. And it will pay even more going forward. And if you have a zoom into each component, then you can see that we have the server here from a schema tables that we use for monitoring. Then we have our APIs, what we call lifecycle, capture, applier. So we intercept transactions going on to get the right sets. We intercept the capture to get the data that they are trying to change. Then on other members, we apply those changes. So we need to have an applier API. And that then will be our plugin components that we call capture, conflict handler, applier, and recovery. Below that, we have our replication protocol that we use. Then we have the group communication protocol component, group communication API, the binding, the engine, and then the network. And these three components was what allows us to replace CoreSync very easily. And then, of course, we have the storage engine, which is InnoDB. So to sum up what group replication is, it is a cloud-friendly solution. It is great technology for deployments where we need elasticity, and such as cloud-based infrastructure, we need to add servers, remove servers. That is allowed from day zero. It's built in. It is well integrated with the server, so we support our APIs, GTIDs, always replication from schema tables. If you have your own monitoring solution for normal replication, you can easily use it for group replication, since we use the same interfaces. Also, it allows autonomic end operations to be friendly with the DBAs. So it is self-healing. There is no need to have manual failover or to implement other things that need well, what will happen when my master fails. The group itself will take care of that. It provides fault tolerance, auto failover. Also enables multi-primary updates everywhere. And also it provides what we say, finally, a dependable MySQL service that was never available out of the box. You could use the MySQL server, add your own pieces and make that, but now we have that available out of the box. It was GA on the ending of last year on 5.7.17 and is now available also on 8.0.1. But this is only the first step and not our goal. So what we want is to give you a rich, mature HA solution on which group replication is one of the base components. Where's my pointer? It went out of battery. Okay, really on the, no. Here. We have here group replication on these three members groups, which are the core of the design. Then each group can be extended with slaves to provide read scale out, and each one will be a replica set. And then on top of that, we have router and applications, and you can make charts and you can make whatever you want, and this will be available all out of the box. Not yet, but we are working on that. And we did release replication on the end of last year. 2 weeks ago, we released GA MySQL Shell and MySQL Router, which is the first step for this picture, and we will release more steps on this periodically. So soon you can expect more news about this. And we'll have eventually a MySQL HA out-of-the-box solution.
No, can I just say one thing here?
Yes, please.
So this is the roadmap and the strategy, our strategy, if you will, and this is our vision. That's more of what I wanted to say. And this is all about what I also mentioned earlier about the InnoDB clusters and having native HA in the MySQL server, being able to deploy it in a simple manner, easy to use manner. You know, at the heart of each replica set, there's a group of MySQL replication servers, and then you have, you know, HA, read scalability. Then eventually we will get write scalability through sharding built into all this picture and so on and so forth. The interesting and exciting thing to me is that I think this very same slide or some variation of this slide was presented, I think it was a year ago or a year and a half ago. A year ago or a year and a half ago, and as by Thomas at his keynote at Oracle Open World. And the exciting part for me is that we see this being executed and delivered in a very interesting and fast pace. So this is, for me as an engineer and a person who works daily on this kind of project, is really, really exciting times. For the end user, I guess it's also very exciting to see all of these things being added together. The key point on all of this is to provide a better user experience, to provide a better story altogether. So all these components are tested together, all these components are thought through together, and all these components are released together. Originally, we're doing this in steps, right? Originally, we delivered the group replication plugin in 5.7. Now, 2 weeks ago, we released the InnoDB cluster tool set around group replication, but already with some reassurance or some assurance that all these things were tested together and should work very well together. So this is, I guess what I'm trying to say is that this is the vision and we're executing on it, as you can see. And this is really exciting times as an engineer working on this, right? So, yeah, and that's pretty much it. Do we have another slide?
Yes, we have one more slide. So before that, if you want to take a look and feel about InnoDB cluster, Frederick made a tutorial on Monday. Of course, you cannot back in time, but you can go to his blog and see and get the slides and try to do it at home or just read it. And you understand how the InnoDB cluster, it's easy and it's really made easy to work from the beginning. And then just to finish, so you can grab our packages. So replication is GA, InnoDB cluster is also GA. Just go to the usual URL and get it. We have our documentation in place, and also the last one is our blog. Go there, get the new news, our fancy blog posts and technical ones, and give us our feedback. And that's it. Thank you.
Thank you.
So, questions? Yes? We do have that, not on the server, but on, Matt, you can correct me, on the shell, right? We have that check made on the InnoDB cluster. Yes. No, but if
there's room for improvement there, Simon. There's room for improvement there, definitely. Yeah.
But if you mention runtime checks, we have runtime checks. Yes.
No, but what Simon says is that he wants runtime checks at the beginning when you issue the DDL and you prevent it if it's not complying. Right.
We want to do that, but that comes from a different team. So
okay, there was a hand here somewhere. Yes, please.
For SQL primary and multiple slave setups, master guide, what is the election process in-house?
The group has a failure detector built in, and once it detects that the primary is down, it will elect a new primary.
Right, but is it like a majority vote to pick up the new slave, or is it whoever's current?
You need a majority to be alive to make that election, and everyone will make the same deterministic election.
No, but the promotion policy is based on, it's very simple nowadays. It's just based on the UUID, which is, let's say, the smaller lexicographical UUID of the servers, remaining servers. They will all sort them and take the smaller one and just pick that one up. There's nothing like a weight or whatever, right? There's no more advanced or complex policy to actually drive the election process.
Yes?
In case I have, let's say, a cluster of 5 nodes, where 3 nodes reside in one data center, and 2 nodes reside in a second data center that are geographically distributed. Do you have currently any mechanism to manage and to fine-tune the packaging, between the 2 data centers at network level or something like that?
Not yet. We have plans for that, but this is our first release. We are focusing on local area network, but yes, we have plans for that. This way, yes.